All right, why don't we go ahead and get started? Good afternoon, everybody. My name's Andrew Mason. I'm a group program manager in Azure Storage, Media, and Edge, working on Azure Stack Edge. Some of you may have seen the title outside or in the program, Data Box Edge. Hopefully this morning you saw in the keynote and Jason Zander's presentation, we've now joined the Azure Stack family. So it's Azure Stack Edge along with Azure Stack Hub and Azure Stack HCI. And joining me today is?
I'm Chris Dickens. And I work with Andrew on the Azure Stack Edge product. And just to kind of continue what he said, like it's the same product. I mean, obviously we have a lot of new stuff to tell you about, but we just did a rebranding today. And so we're excited for those of you that knew Data Box Edge to, also know Azure Stack Edge. It's gonna be great.
Yes. Yeah, and so we'll get more into, in addition to the name change, we've added a bunch of new capabilities that are coming. So we'll talk through a lot of the existing as well as new capabilities. So, at Microsoft, we have this view of intelligent cloud, intelligent edge, where you have this hybrid capability and consistency across those. And so that's really important, and really what Azure Stack Edge provides to you is that consistent layer where you can deploy compute and run compute closer to where your data is being generated out at the edge. And so we'll dive in and spend a lot of time talking intelligent edge with Azure Stack Edge. But first, I want to talk a little bit about the taxonomy around intelligent edge and cloud here at Microsoft. So on the far end, you have your hyperscale cloud, you have your Azure data centers. Going down and slowly getting smaller, you have Azure Stack Hub, which allows you to deploy a set of Azure services on-prem for disconnected data sovereignty environments. Then below that, you have Azure Stack Edge, where you can go closer to where your data is being generated and process your data before transferring it to the cloud or even discarding it locally. Then you have a set of smaller devices going down through Azure IoT Edge, the IoT SDK, all the way down to Azure Sphere, which is a microcontroller that allows you to build your own sensors and devices. And as you can see across the bottom there, in the cloud data center, you have the fewest number of form factors, but the most services. And as you go down the spectrum, the number of form factors increases, but the number of services decrease, because the amount of compute capabilities when you're all the way down at something like Azure Sphere are much less than what you would have on Azure Stack Edge. There's number one. I told Chris I was going to mess it up multiple times today. On Azure Stack Edge, Azure Stack Hub, or even in the cloud. So let's start with Azure Stack Edge. So it is a managed edge appliance that brings the compute capabilities of Azure to your location, to where your data is being generated. And you'll notice a few things on this slide that we'll get into more details on, some of the announcements we're making today. When we announced what was Data Box Edge at Ignite last year and then launched it in March this year, it had an FPGA in it to allow you to do accelerated ML inferencing. We're releasing another version that will have a GPU in it. So if you have ML models that run on a GPU, you can easily run them on Data Box or Azure Stack Edge. For running compute at the edge, we've supported containers since the beginning. We're adding VM support, and we'll get into more details on both of those a little later. And it is an Azure managed edge appliance. So when you get the device, it's very much like setting up a home Wi-Fi router. You connect it to power, you connect it to your network, you connect to a well-known IP address on it from your laptop, and you use a little local web UI to configure the IP addresses for the NICs in the device. And then you put in an activation key from the Azure portal, and then the rest of your management is done from the Azure portal. So if you have these deployed across many locations from the Azure portal, you can push out new containers, new VMs, and manage your entire environment across, maybe you're a retailer, across to all your stores, rather than having to connect to each store or send somebody out to the stores to do something. And it does have a storage gateway built into it. So if you have the need to transfer some of that data to the cloud for further analytics or processing, you can use the storage gateway to move that data to the cloud. And we'll talk about all these different pieces of Azure Stack Edge as we go today. So at a high level, the use cases for Azure Stack Edge are around machine learning at the edge. So doing your ML inferencing quickly and close to where the data is being generated so you can get a result. Edge compute and IoT solutions. So being able to process your data or run compute for whatever your need may be. You could even run legacy VMs on it with our new VM capabilities. And then that network data transfer from the edge to the cloud. So let's look at each of those in a little more detail. So using ML at the edge, you can process at the edge for immediate results. There's lots of data being generated outside of the Azure data center or even the traditional data center with the explosion of cameras and IoT sensors. And in often cases, that's data you want to process right then and there because you want to be able to act on it very quickly, not wait for it to round trip to the cloud, or maybe you're in a location with high latency, limited bandwidth, whatever other reason, but you want that result quickly and close to where the data is being generated. So for like a safety scenario, you could be processing the images off your cameras at a construction site to make sure everybody's walking in with their hard hat on. And if somebody walks in without their hard hat, you want to know that right then and there. When your internet comes back in the afternoon, that doesn't do you any good to know somebody walked in at 9 a.m. without their hard hat. Filter with AI analysis at the edge. So you're generating lots of data at the edge. That may be more data than you have the bandwidth to upload to the cloud. And so you can filter down and find those important pieces of data and upload just the important pieces that you want to do further processing or analytics on. The example here around collisions or near collisions is actually something one of the cities in Washington State's doing, where they have all these traffic cameras, which is great when you want to look at your commute and see what traffic's like, but that's not really data you need to store for the long term. But what they have is an ML model that detects collisions or near collisions, and then they save some of that video leading up to that collision so that they can have a human look at it and determine, what changes can we make to the traffic patterns to prevent that kind of accident from happening in the future. Or you can even remove sensitive data. So if you have certain regulations or compliance requirements that prohibit you from storing certain data in the cloud, you can use ML to filter that out of your video or images before you upload it. So like blurring faces or license plates in autonomous driving data. So an example of a customer using ML at the edge is Kroger. Their Sunrise Technologies division earlier this year at NRF with Microsoft announced they're working on a retail as a service platform. And so what they're doing is they're actually using a bunch of the existing cameras and technologies they have in their stores and getting additional value out of that imagery. And so that imagery is coming into Data Box Edge. They have an ML model that detects out of stock, so voids on the shelves, and then they can notify somebody in the store that they need to go restock that product. So like the Cheerios are out on aisle 3, go restock that, rather than waiting for somebody to ask about the Cheerios or some employee to walk up and down the aisle and notice that. So they can get the products restocked much more efficiently and quickly and keep selling Cheerios. So they were really using a lot of their existing infrastructure to do that through Data Box Edge. And again, this is an example where, that's important in the moment, but that image where there's a void on the shelf isn't data that they necessarily have to upload to the cloud unless they want to use that to retrain their models. So in the case of somebody like Kroger that has thousands of stores, a lot of those stores don't have high bandwidth. They can just process it locally, act on it locally, and then discard it. Where they do have high bandwidth, they can be sending those to the cloud to retrain their models. So on the edge compute side, you can use the edge compute to run business applications at your facility. So maybe you need to push compute down to a location, branch office, retail store, where you want to run the point of sale system or other infrastructure within the store. You can push containerized or VM workloads down to a Azure Stack Edge and run that compute locally and process the data there. You can also use it as a bridge between your on-prem systems and the cloud. So maybe you have limited bandwidth or you have applications you need to run in your environment that can't move to the cloud. Well, you can modernize those, taking advantage of some cloud capabilities while running on-prem and be connected to the cloud and integrate with pieces of that application or other services you may be using in the cloud. So you have that connectivity and consistency I mentioned earlier between on-prem and the cloud. Or even take applications out into the field. So being able to run disconnected for periods of time, oil and gas exploration, other scenarios where you may need to go out into the field where you're collecting and processing data that you might want to act on in the moment. How many people were at the Jason Zander keynote earlier today? All right, a few hands. So we talked a little bit about Esri in that one. They're a company that's using Data Box Edge. They do a bunch of different types of mapping software. And around disaster recovery, they send a Data Box Edge out in the truck with various sensors, cameras, drones, collecting data and imagery that can then be ingested into Data Box Edge and overlaid onto the maps. So the disaster relief workers know, the bridge is out up ahead or the tree is down. That's all local updates they can make to the maps. And then when they come back, that all gets uploaded and combined across all the vehicles. And then there's also network data transfer to the cloud. So maybe you have all the sensors and cameras and other things in your environment generating data. You can use the gateway capabilities in Azure Stack Edge to transfer that data up to the cloud on a consistent basis. You can also use it for big data migrations. So maybe you, the example on the next slide is a customer that I will talk a little bit about now. Maybe you have a lot of data for different clients that you want to offload when a particular project's done. You could use it for the data transfer. It handles transferring that data when bandwidth and internet connectivity is available, so you don't have to worry about managing the transfer of that data to the cloud, or even managing bursts of data. Back to sort of that oil and gas exploration, autonomous driving. Somebody comes back with a whole bunch of data, back to a location that's network connected. You can then use this to transfer all that data to the cloud for you, to run all your cloud scale compute and analytics on the data. So Hogarth is an example of a customer using Azure Stack Edge for data migration. So they are a media company that does advertising and other collateral like that. When a particular project is done for a client, rather than storing that all in on-prem storage, they move it to the cloud. So they use Azure Stack Edge as the way to transfer that data up to the cloud.
Thanks, Andrew. So Andrew talked through a lot of the use cases, and I'm going to kind of start talking through some of the technology that underpins those use cases that helps us to kind of ground what can be done on Azure Stack Edge and how it works. And so there is a lot of overlap because there's similarity, but in general, we talk about the hardware accelerated machine learning is like a core part of the technology platform, edge computing capabilities, and then that it's an Azure managed appliance, which is a really important concept, that you have this appliance that you order from Azure, it shows up where you are, and then it sort of operates as an appliance more than as sort of a traditional server that you might know. And the key there is that you manage the thing from the portal. So my favorite example is if you have to update, if there's a new update of software available, you just go into the portal and you click a button and the device will automatically update for you versus having to sort of be out and do all the things locally or where the things are or where the device is. And this really allows you to sort of start to deploy this infrastructure to places where maybe you don't have IT people or maybe you don't have to figure out how to route network traffic out to all those field locations because you don't have to go and reach out to the things. You can just sort of do it all from the cloud. And then, like Andrew talked about, there's the cloud storage gateway that can transfer data directly from Azure Stack Edge to the cloud and also sort of read back. So when we get into hardware accelerated machine learning, right, we talk about how the ability to process data locally where it's generated for immediate results. And then you can use those results to take action, right? And so there's a lot of different things you can do. So sometimes that's you process that data locally, and then you have an immediate result, and you tell some other local system to do something, right? So the classic example of this is you have some piece of machinery, and you're watching the sensors to make sure that everything is operating correctly. And if you see something that looks anomalous, you tell the machine to stop right now before it breaks itself or breaks or hurts somebody. And so you have to have very fast communication to do that. You have to be operating on premise. But also there's the idea of being able to go back up to the cloud. So you could have events, right? So you could be watching a stream of data, watching a video stream or something, and you could see an event happen in that video stream and send that event, just the metadata, right, up to the cloud. And then you can have a cloud dashboard that looks across, sort of all your things. And these especially are concepts that if you come to some of our other sessions later in the week, there's 2 on Thursday that you can kind of hear more about. We're going to talk a little bit more about some of these scenarios. And so the key here is that you see this concept of like, you have data that comes in, you process it locally with local machine learning that's accelerated with the hardware, and then you can have information flow up to the cloud and also flow to your local systems. So as Andrew said, right, we've announced that we're making a version of Azure Stack Edge, making a version of Azure Stack Edge with an NVIDIA GPU in it. And what that allows us to do is it lets you do sort of like a full breadth of hardware acceleration and sort of all the things that NVIDIA GPU supports. The current version that we have today with the FPGA, we accelerate with Azure Machine Learning tools. And there is a set of Azure Machine Learning ML models that sort of are optimized for the FPGA. And so you can get those models, you can train them in the cloud, get transfer learning, and then deploy them to Azure Stack Edge. And you don't have to kind of know how to program in an FPGA, right? Those Azure ML models sort of know how to do that for you. They know how to be optimized on the FPGA. And then, like we were talking about with the GPU, right, the full kind of standard set of industry support for the GPU will work as well on Azure Stack Edge. So things like, Azure ML, Onyx, the NVIDIA EGX and DeepStream systems, and we have a preview for that kind of coming soon, right? So, but we do have a box on display over in the hardware showcase that has one of the GPUs in it. So we're really excited, personally, like this is my favorite thing, about the new compute functionality that we're working on for Azure Stack Edge. And one of the keys here is that the IoT Edge functionality that it has today sort of remains, right? And IoT Edge is a great system for sort of managing IoT devices and managing kind of IoT solutions, deploying containers out to the edge. IoT has sort of a whole system for doing that deployment. But what we found over the last year of kind of talking with customers about the product and talking with them about the things that they want to run on and they want to build on it, is that we also need some key industry standard things to run on Azure Stack Edge to provide sort of flexibility. And so the two things that we're working on, which are great, are Kubernetes and virtual machines. And with Kubernetes, and with both of these, you have the ability to sort of take your workloads that you want to run out on the edge, deploy them from the cloud, manage them from the cloud, and then sort of use those sort of the standard ways that you're used to working with some of these technologies, and just use Azure Stack Edge as sort of your platform for running at the edge. And then you get a cloud-managed edge platform in addition to all the things you're hearing about this week around managing these services out at the edge. So we let you manage that underlying platform as well. So I'll talk some about Kubernetes on Azure Stack Edge. Once again, we have a preview coming soon for this. And so what it allows you to do is it allows you to take your Azure Stack Edge device or multiple Azure Stack Edge devices and automatically turn them into a Kubernetes cluster. And then that gets managed by the Azure Arc Kubernetes system that you may have heard about so far this week, and there'll be lots more information. So it allows you to deploy workloads down into that device. And so it lets you sort of manage this whole thing end to end, where you can use Azure Stack Edge to manage the underlying hardware, and then use Azure Arc to sort of deploy into it from the cloud. And it lets you sort of have like kind of a hands-off and simple thing. So also in Jason's keynote this morning, they sort of talked about this a little bit. And my favorite part about it is the idea that, Kubernetes is hard, right? There's a reason why there's all these sort of Kubernetes services in, the cloud platforms, right? AKS is Azure's sort of version of this. And you have this, like the ability to like just sort of have that same kind of managed Kubernetes experience where you just get some devices and say, give me Kubernetes, and we make you Kubernetes instead of you having to fiddle with it to stand it all up and make sure it works. Super valuable. And so when you start talking about deploying things into those clusters, right? Obviously you can write your own containers and you have your own containerized systems. But one of the key ideas is that many Azure services also have sort of edge versions of their services that sort of run in these containers. So there's cognitive services, machine learning, stream analytics, functions, there's AI toolkits, and sort of the SQL database edge software. And there's more coming soon. It's one of the things that we're working on a lot, is this idea of like being able to deploy these Azure services out to the edge and be able to run them in the sort of these true hybrid fashions. We've talked to a lot of customers who want to do edge computing And especially the thing that we see a lot is that they want to use software from a vendor that just frankly isn't in containers. Happens all the time. We talk to people a lot. And so we know that we need to bring the ability to run virtual machines to Azure Stack Edge, because that really is what allows you to sort of support really almost any software, right? Because you can sort of install it into a virtual machine, you configure that virtual machine, you can deploy that out to the edge, and then sort of make sure it keeps running from the cloud. And so, what we're talking about today, also a preview coming soon, is that it lets you run your VMs at your location, deployed and managed from Azure. And it's great for compute tasks, right, that aren't in containers yet. It supports both Linux and Windows virtual machines. There's this key here about it's designed for basic configurations, right? So one of the things people sort of ask about is how is Azure Stack Edge different than Azure Stack Hub? And Azure Stack Hub really brings you sort of the full power of the cloud. And part of that power is complexity that a lot of customers really need, right? You need the ability to do complicated network kind of environments between your VMs and set up, all kinds of load balancers and things around VMs. And Azure Stack Edge VM support is really designed to just be a simple platform where you can deploy virtual machines to that spot and sort of let them run in that place. And what that allows for, that simplicity, is sometimes limiting, but it's sometimes freeing, right? Because it's sort of sometimes easy to operate. And so that's sort of our goal there. And it's one way to think about if you're thinking, oh, is Azure Stack Hub right for me, or is Azure Stack Edge right for me? One of those core pieces is going to be around sort of the complexity of the configurations that you need, because we're really designed for some of those more simple and basic configurations. So, we talked about Esri a few minutes ago, and I showed some Esri things in Jason's keynote. And one of the key things with Esri is that while they are doing containerized, they have some containerized software. Most of their software doesn't work in containers yet. And so the ability to have virtual machines is one of these examples that I talked about, where you can get it opens up the broad range of Microsoft partners for bringing services out to the edge to be able to run in virtual machines. So with Esri, I'm going to talk a little bit more about the same Hurricane stuff I did today. And I just want to say up front that Hurricane Michael was a terrible, tragic thing that impacted a lot of people in this area. And we're really sensitive to that. And so when we're working with Esri on these things, Esri has this disaster response team that goes and spends a lot of time and energy working on how to make those responses better. And we're working with them to sort of help them, give them sort of the computing power to bring some of the tools that they have and they're doing sort of out into the field and help. So we're just going to show a little bit about that. But I know this can be sensitive stuff, especially in this area. So I'm going to sort of stay away from some of the specifics and some of the detailed stuff. So after Hurricane Michael, this Florida Civil Air Patrol flew airplanes over the area. And what's really neat about this is actually this sort of spiral diagram is the real track of where the airplane went, because the airplane was flying around and it was taking sort of pictures from a high-resolution camera in the air. And those pictures were all geotagged with where the picture was taken from. And then when they imported it into Esri software, right, it can figure out where the pictures were all taken from the geotags. And you can see this sort of circular pattern lets it sort of get a different angle on all these pieces. And then the pictures on the right-hand side of the screen are the actual real pictures that that they took from the airplane. And so you can see they're all skewed and around in different places. So the ability to make sense of them is going to be really important, because it would be hard to just sort of look through pictures like this and try and figure out sort of what was going on. So, and that's sort of what we kind of talked about today. And actually, I'm going to start here in the sense that with Esri running in virtual machines on Azure Stack Edge, you have the ability to kind of have their whole sort of software stack, their sort of server portal running on the machine out in the field. And so this is actually, I'm just going to be super upfront. This machine is not here. It might be a little bit slow. It's back in our office. But this is running on an Azure Stack Edge device in a virtual machine. And it sort of can have their whole portal. You can do all these things. You can create You can create layers and scenes, and you can put the scenes together, and you can kind of have it run analysis for you. And so when we take all those pictures and you stitch them together with the Esri software, it turns into this map, right, that allows you to kind of get a sense of what's actually happening on the ground. And with that map, you can kind of sort of move around a little bit. But what's really cool is like you bring some extra processing to it, and they can actually turn that into sort of a 3D representation because they have all those different angles, right? So it's sort of the same thing you see in sort of like the online mapping tools where they sort of make 3D views of things. You can do that same piece kind of out at the edge with the software that's sort of enabled because of VMs, right? Because this stuff doesn't work in containers yet. You can move around the environment. You can get a sense of kind of what's happening there sort of immediately from sort of the truck instead of having to drive around and go to all these different places. One of the things that I learned in talking with Esri that was really interesting, because it always sort of strikes you, it's like the little things are the things that get you. Like the most important thing after one of these disasters is to actually get an accurate damage estimate for how much damage has been done, because that's the thing that activates all the like federal relief efforts and all those sorts of things. And so the ability to kind of go there and get a sense of the actual damage and what's actually happening is really important. And to that end, another thing that Esri's done is they've added sort of some AI functionality that lets them sort of look at those images that we talked about and sort of detect which buildings they think are damaged or not damaged, right? And so you can kind of see they've sort of done this area that I just showed a moment ago, and sort of we have this overlay of sort of blue and red for damaged and undamaged structures. And that sort of helps them to kind of like, once again, it helps you out in the field to be able to sort of analyze that information right there. And it's a thing that virtual machines make possible because their software doesn't yet operate in containers, or this software doesn't yet operate in containers. Cluster. Okay, yeah. So, and then the last sort of main compute feature that we're talking about today is the ability to cluster multiple Azure Stack Edge devices together. And so you can take many of them and you kind of move them together. And then, of course, run Kubernetes on top of them, right? That's one thing you can do with that cluster. But also the sort of the storage gateway storage that happens can all be clustered together to get resilient storage or to expand your storage capacity. And then your ability to sort of run virtual machines across multiple devices in the cluster also helps you with both high availability and with load.
Thanks, Chris.
Yep.
So let's talk a little bit more about cloud managed. Both Chris and I mentioned this a couple times. Essentially, everything's managed from Azure once you have Azure Stack Edge configured. And it's easy to order, so we have a unique business model with Azure Stack Edge. You don't have to go out and buy one of these devices. Essentially, you subscribe to the service, Azure Stack Edge, and as part of that monthly subscription fee, we send you a piece of hardware to use. You can return that at any time. There's no minimum time period you have to keep that for, so you could try it out, and for your solution, if it's not a fit, you can send it back, and we'll stop billing you. When we come out with new versions, like we're announcing today, the GPU version, if you happen to have an FPGA version of the device, you can swap your device for the GPU version. When new cool Edge hardware comes out that we include in the next version of Azure Stack Edge, you could swap for that one as well. So this shows up on your monthly Azure bill. You don't have to go out and make a big hardware commitment and depreciate that. You're getting your hardware as a service, essentially. And as I've mentioned, the management is from the cloud. So there's an Azure portal experience for Azure Stack Edge where you manage the shares on the device, you manage the compute on the device, you can deploy containers to it, VMs are coming to that experience. So it all is fully managed from the cloud, and it uses all the standard Azure management tools. So the logging experience you get in the cloud and the monitoring experience is all consistent with other Azure services you may have used. And then Azure Stack Edge also has the ability to be used offline. So we've talked a lot about some connected scenarios where you may want to transfer data to the cloud. Talk some about some of the disconnected scenarios like the disaster relief, oil and gas exploration. Well, there's a couple different ways you can use Azure Stack Edge in a disconnected environment. So maybe you have it out on the ship, collecting data from all the sensors on the ship, the engine and things, processing that, so you can raise alerts to the crew that maybe the engine's overheating or there's something wrong, or when they get into port, schedule predictive maintenance on that. But what you can also do is you could have it completely disconnected. So it's running on the ship, connected to the local network on the ship, processing, sending signals to other systems within that. But you can also do a partially disconnected mode. So there's actually a setting on the device where essentially what that does is it disconnects the gateway from the cloud. So the gateway will not try and transfer any data, but you can still manage the device. So like if you wanted to push out an updated VM or a container over that satellite link, you could do that. If you want to change permissions on a share, you could do that from the Azure portal remotely. But we're not going to consume your satellite connection trying to transfer all the data. When the ship comes back to port, you can put it back into connected mode, and all that data would get uploaded as needed. And so we've been talking a lot about the compute capabilities and mentioned the ability to transfer data. Well, that's because there's a storage gateway built into Azure Stack Edge. And this exposes SMB and NFS on your local network, so data can be transferred in from legacy systems and be processed by those same compute containers or virtual machines in the future, or you can just use it as a standard storage gateway if you need to transfer data. So when data comes in and lands on the device, when you're set up for the share as a storage gateway, as soon as that data lands and there's connectivity, the gateway is going to start transferring it. So the gateway is really a data transfer gateway. When you have compute set up, there's a local share and a cloud share. The data comes in on the local share, and then it's up to your compute to process the data and tell the gateway what, if any, data to send to the cloud. So that's how you could process your images using your ML model, get a result, tell your employees to go take some action on that and discard that image. It never has to be transferred by the gateway. Now, we do cache the data locally, so as you're transferring data through Azure Stack Edge, as the cache fills up and the data's been transferred to the cloud, we'll delete the local copy of the data, but keep metadata so it looks like the files are still there. So if you need to go re-access something, you can, and we'll pull that data back down from the cloud for you. So it is really all about doing a local network copy. The gateway then abstracts away any of the latency, timeouts, retries needed in that transfer to the cloud, so you don't have to manage that yourself. We also have some capabilities that if you look in our documentation around bandwidth throttling, so you can set up schedules to limit the amount of bandwidth. It's like during normal business hours, you could reduce the amount of bandwidth the gateway might use to transfer data, and then let it transfer full speed overnight. And so we've also made a version of that gateway available as Azure Data Box Gateway. This is a virtual appliance, so it is a VM that you go download that runs on either Hyper-V or VMware. So if you just need to transfer data, from a remote location, maybe you don't need to pre-process that data or act on that data locally, you can use the Data Box Gateway to set up a storage gateway that allows you to transfer that data to the cloud. It is all cloud managed, and so it uses the same management experience as Azure Stack Edge.
So this is our sort of, architecture slide, right? It kind of brings it all together. And what we want to talk about really is this idea that you have Azure Stack Edge locally at your site, and kind of just sort of go over all the pieces that we talked about, right? So you have the local edge compute, either via virtual machines, Kubernetes, or IoT Edge. You have the hardware acceleration that local compute can kind of use and access. You have all kinds of on-premises devices or sensors that might be communicating in to Azure Stack Edge. And then also on-premises systems and data, right? So maybe those are just your local storage, or it could be sort of legacy on-prem systems that you want to kind of have a pipeline of that data to the cloud, or you want Azure Stack Edge to be reading information from sensors and cameras and getting insights about that, and then shooting kind of instructions to those local systems for things to do. Those are all things that can happen because it's running there in your environment on your local network. And then it has sort of three main communication channels to the cloud. So one is that you have an Azure Stack Edge resource in Azure, just looks like a normal Azure ARM resource. That's the thing that manages the underlying device and manages the platform. And then each of those pieces of compute functionality sort of have a management plane in the cloud. So they'll manage, manage how those compute functionality is running or what's running there. And then the storage gateway connects the local storage that's in Azure Stack Edge to the Azure Cloud Storage. And then once all those pieces are in the cloud, right, like especially the storage and the other things in the control planes, like they can work with all the other Azure services, right? Because you're up in the cloud, and so they can interact with data lakes and virtual machines and Kubernetes clusters in the cloud and all sorts of things, right? Because you can sort of build that sort of hybrid pattern of an app on the edge and an app in the cloud.
And so when we first launched Data Box Edge back in March, we had the one device with the FPGA in it. With Azure Stack Edge, we've now expanded the family to be 4 different devices. So there's the FPGA version, the version with the GPU, and then there's 2 rugged devices. We have 3 of these down in the booth, so if you want to go check them out. The GPU version and the 2 rugged versions are down in our booth in the hub area, if you want to take a look at them. And then I have a short video that talks a little bit about shows off some of the rugged capabilities. So based on where you need the ability to run your edge compute, we've got a device that can fit in those environments for you. The next slide here has the specs for the commercial devices, both the FPGA device and the GPU device. You can see they're pretty similar other than the FPGA versus GPU. We're still trying to decide on the final storage configuration. So if you have any feedback on how much storage you need with your GPU devices, we'd love to hear that feedback. For the FPGA device, we've both heard that that's too much and too little, the 12 terabytes. So we'd love more data points to help us make a decision there. And then Mil5 is a partner that actually worked with Olympus, who, if you go to YouTube and search on Olympus and Data Box Edge, there was a couple of videos we released over the summer and at Build earlier this year. They have seen, and we're seeing this with a lot of the customers we're working with, that lots of customers have existing video cameras and sensors in their environments, and by plugging in Data Box Edge with that data coming off of those sensors and cameras, they can get additional value from them. So like the Kroger example, they have cameras already in their storage, things they can use those out of stock detection and help reduce the time it takes to restock product on the shelf, driving up their margins. And so there's lots of ways with partners to get those ML models created to drive solutions forward on top of Data Box Edge.
I'll just add that Shri is here in the audience too. Hi, Shri.
And
Shri's been a great partner in building solutions on Azure Stack Edge.
So just in summary, we've got a couple minutes left. This slide is, again, sort of the data sheet for Azure Stack Edge. Hardware accelerated machine learning at the edge, either FPGA or coming soon a GPU. Edge compute running containers today, VMs coming soon, Kubernetes coming soon. It is Azure managed, cloud storage gateway, all those capabilities we've been talking about. There is a great demo showing off Azure Stack Edge and some of its capabilities in the Intel booth. So if you want to see some of this ML inferencing in action on an Azure Stack Edge, stop by the Intel booth. As Chris mentioned, we have a couple sessions later this week going into Kubernetes on Azure Stack Edge, as well as just deeper dive on edge compute. And then in the hardware showcase, we have 3 of those devices on the earlier slide. As we've said a few times for the GPU, virtual machines, Kubernetes, clustering, previews are all coming very soon for those. If you're interested in joining the preview, follow the URL on the slide there, aka.ms/Azure Stack or Stack Edge previews, and you can sign up for the previews. We'll get in contact with you, get you some hardware and the bits to try out some of these new capabilities at the edge. And so with our last couple of minutes, we can open it up to questions. Anybody has any questions? There are some microphones here.
Yeah, well, I'd like you to use the mic if you could.
I think try again. There we go.
With the disconnected version, what's the ordering process going to be? So obviously connected, you do it through the Azure portal. Disconnected, maybe you've not got an Azure subscription for it. What's the process going to be for that?
So a core concept is that it doesn't actually run fully disconnected or always disconnected. It's that you still order it connected to your Azure account, and then you configure it through the cloud, and then when it goes offline, it can continue to operate in the way that it's been configured, and there are certain things that you can sort of add and change the configuration for, but then it's expected it would like kind of come back online. It's frankly not a good fit for if it just sort of will always be disconnected all the time. You'll want to look at, yes.
There is an exception to that, always disconnected, in that
That's right.
we are working on, although it's a little too early to go into preview for that, being able to use Azure Stack as your cloud. So you could have an environment where you're fully disconnected with Azure Stack as sort of your cloud with your services. Azure Stack Edge would connect to that and be provisioned from that.
That's good.
Probably coming sometime next
So the
calendar
question
year.
is then, what will the ordering process be for that, or is it you still got to work out the logistics?
We gotta work out that.
Yeah.
Work that out. Yeah.
Thank you.
Yeah.
My question is, when you taught us about the storage gateway functionality, so is this the replacement for Store Simple then, or?
So in some use cases, yes, it's the replacement for Store Simple. If you're using Store Simple as a way to move data to the cloud for archival further processing in the cloud, this is a great replacement solution for that. If you're using Store Simple more as an on-premise NAS file server type solution, Azure File Sync is a replacement.
There's actually, we have a theater session later this week talking about Store Simple stuff.
Store Simple, end of support, and migration, yes.
Yeah, cool, thank you.
Yes.
What's the largest number of devices deployed by one customer?
The largest number of devices at a customer
Yeah, deployed.
deployed? I think the largest right now is 8. There's one customer that has 8 devices.
Okay.
A lot of customers are still doing POCs and building out their solutions in their environment and starting to test them. We just GA'd in March of this year.
Thank you.
That was a great presentation. You mentioned Azure Data Box. I thought, where does Azure Data Box fit, or what is happening with that, or is that being replaced with this technology?
Yeah, sure thing. So there's the Data Box family is really about sort of getting your data from where you are to Azure. And so we have a whole range of Data Box offline transfer devices that are also in display in our booth over there. So there's like small, medium, large, depending on how much data you have to move, all the way up to a giant 1 petabyte device that can move data for you. And so those are all we send you a device, you copy data to the device, and then you ship the device physically to us if we copy it into the data center. Data Box Gateway that Andrew mentioned is an online sort of virtual appliance that you can use to copy data online. And then Azure Stack Edge is really more of an edge compute appliance that also has a storage gateway built in. Yeah, sure thing.
So the Data Box family and branding is staying sort of more on the solutions focused on data transfer. This one, we're seeing a lot more compute usage and edge processing and ML inferencing, so we're joining the Azure Stack family for that one.
We have the red light now, so I think that means we're all done on stage, but we'll hang out for a little bit
Yeah,
and
we'll
answer questions for sure.
Thank you, everybody. Don't forget to fill
Thanks
out
so
the
much,
eval.
guys. Yeah, please fill out the surveys. They help, and they really, we appreciate it knowing how to make better presentations and have a great conference for y'all. Thank you.